Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LJIT. Earlier lecture, we are already discussed about the Cauchy's root test and Leibniz test for alternating series and few summarize of the infinite series which test is applicable such kind of example. Likewise that today's session we are going to discuss about the absolute and conditional convergence of the series and power series. Let's see the firstly absolute and conditional convergence. If the series sigma mod of u of n is convergent, then given series sigma un is absolutely convergent. Now let's see the for the conditional convergence. If the sigma un is convergent but sigma mod of u of n is divergent, then we can say that given series is conditional convergent. Here we have the two series sigma un and sigma mod of u of n. If sigma mod of u of n convergent, then automatically sigma un is convergent. Means un and mod of u of n both are convergent. Then we can say that given series is absolute convergent. Means sigma mod of u of n convergent. Then no need to solve the sigma un. It is automatically convergent according to the theorem. Here, let's see the one theorem. If the series sigma un is absolutely convergent, then we can say that given series sigma un is convergent. But the sigma mod of u of n divergent, then we have to check the given series sigma un is convergent or not. If it is convergent and mod of u of n is divergent, then we can say that given series is conditionally convergent. Here, let's see the one not. If the convergent series is positive term series, then it is obviously absolutely convergent. Now let's see the one example based on absolute or conditional convergence. Determine absolute or conditional convergence of this series. Summation where n is running from 1 to infinite minus 1 raised to n square upon n cube plus 1. Here obviously un equal to minus 1 raised to n into n square upon n cube plus 1. For the conditional or absolute convergence, firstly we have to check the modulus of series, means mod of u of n is convergent or not. Then mod of u of n becomes n square upon n cube plus 1 because it is modulus which is absorb the negative sign. Then it is positive term which is n square upon n cube plus 1. Here mod of u of n has a in terms of polynomials form. Then which method we can applicable, or which is also called the different power of n in numerator and denominator portion. Then we have to apply the comparison test, correct? Here, then according to the comparison test, we have to find the Vn. Then how we can find Vn? Then dominant term of the numerator portion and dominant term of the numerator portion. Here Vn equal to peak term or maximum value of numerator portion which is n square, in denominator portion which is n cube. Then ratio of n square by n cube, that it becomes 1 upon n. Now according to the condition of comparison test, means limit n tends to infinite, mod of u of n upon Vn. Now substituting the values of un and Vn and simplified it, then it becomes 1 upon 1 plus 1 upon n cube. Now applying the limit n as infinite, then 1 upon infinite, that is 0, means 1 upon 1 plus 0, that is 1, which is finite and non-zero term. Now let's see the Vn is convergent or not. Then according to the P series, summation Vn equal to sigma n equal to 1 to infinite 1 upon n. Then here value of P, that is 1, means according to the P series, given series sigma Vn is divergent. Now both the series either convergent or divergent together, means sigma Vn is divergent. Then according to the limit comparison test, we can say that sigma un is also divergent. That means sigma mod of u of n is divergent. Then we can say that given series is not a absolute convergent. Now here mod of u of n is divergent, then we have to check sigma un is convergent or not. Here un equal to minus 1 raised to n into n square upon n cube plus 1 means obviously given series is a alternating series. If given series is alternating series, then which test is applicable? Everyone knows that. Here we can use what obvious Leibniz test for alternating series. Then Leibniz test has basically two conditions. First, mode of u of n which is greater than mode of un plus 1. Secondly, limit n tends to infinite, mode of u of n equal to 0. Let's see the first condition we have to check. Then for the first condition, we have to difference between two consecutive terms, mode of u of n minus mode of un plus 1. Now substituting the values of un and un plus 1 and give the simplification and expand the brackets and cross multiply, and we get here n raised to 4 plus 2n plus 1 into n square minus 1 in denominator portion, n cube plus 3n square plus 3n plus 2, another bracket n cube plus 1. In this term, substituting the n equal to 1, 2, 3, 4, 5 and so on, then must be answer which is greater than 0 for all n belongs to n. That means we can say that mode of u of n which is greater than mode of un plus 1. That means each term is numerically less than its preceding term. That means our series is in form of decreasing form. Means first condition which is satisfied. Now let's see the second condition of the Leibniz test for the alternating series. Here limit n tends to infinite mode of u of n. Now substituting the values of mode of u of n and numerator and denominator portion n cube which is common and cancel out, then it becomes 1 upon n inside the bracket 1 plus 1 upon n cube. Now applying the limit n as infinite, then it becomes 0. Then second condition which is also satisfied, then we can say that given series sigma un is convergent according to the Leibniz test. That means given series sigma un is convergent, but sigma mode of u of n is divergent. Then we can say that given series is conditionally convergent. Now let's see that we have to check out the one more examples of it. Determine whether the series summation n equal to 1 to infinite cos n upon n square. Now substituting the n equal to 1, 2, 3, 4 and so on, then it becomes cos 1 upon 1 square plus cos 2 upon 2 square plus cos 3 upon 3 square and so on is convergent or divergent. Here obviously un equal to cos n upon n square. Now normal values of cos n which is lies between minus 1 to 1 means some of the term which is negative and some of the term which is positive. But whenever we substitute the values of n equal to 1, 2, 3, 4 means cos 1 that is positive, cos 2 negative, cos 3 negative, cos 4 negative, again cos 5 that is positive, means first term positive, then 3 term again negative, again 3 term positive, 3 term negative and so on. Means given series has a positive and negative both terms are present, but it is not a alternating series. That means we cannot go for the Leibniz test. Means here we have to taken the value 1, 2, 3, 4 in form of radian form. Means here we have to apply direct comparison test and we have to check the modulus of u of n. Means negative value will be absorbed. Now maximum value of mode of cos n which is 1, then here un equal to mode of cos n upon n square which is less than or equal to 1 upon n square. Then here 1 upon n square that is our Vn. Then according to the P series, sigma Vn equal to sigma 1 upon n square, then value of P which is greater than 1 means value of P equal to 2 which is greater than 1. Then according to the P series we can say that sigma Vn is convergent. Now here condition has either both the series convergent and divergent together, then automatically sigma mode of u of n is also convergent by the direct comparison test. Means mode of u of n is convergent and u of n is also convergent according to the theorem. No need to solve it. Then we can say that given series sigma un is absolutely convergent. Now let's see that. Check out the next upcoming topic which is power series. A series is form of summation n equal to 0 to infinite an x minus a raised to n. Now substituting the values of n as a 0, 1, 2, 3 and so on, then a0 plus a1 x minus a plus a2 x minus a whole square and so on is called the power series in powers of x minus a. Or we can say that the series which is center at a, or we can say that power series about the point x equal to a. Here x is a variable and a0, a1, a2, a3 and so on are the constant, or we can say that coefficient of the series. Now let's see the examples of the power series or in terms of variable form. Here 1 upon 1 into 2 into 3 plus x upon 4 into 5 into 6 plus x square upon 7 into 8 into 9 and so on, where x greater than 0. Then firstly, in this type of particular example, we don't have a nth term. Then firstly, with the help of arithmetic progression, we have to find the n terms of this series, that is un. Here in numerator portion, first term has a 1, then x plus x square and so on. Then we can write x raised to n minus 1, where we have to starting with n equal to 1 to infinite. Suppose we have to starting with n equal to 0 to infinite, then we can write x raised to n as you like. If you want to your series which is starting from 1 to infinite, then we can write x raised to n minus 1. Suppose you have 2 starting with series n equal to 0 to infinite, then we can write x raised to n as you like. In numerator portion, each and every denominator term has a first term consider only, the 1, 4, 7 and so on. Then difference between these two terms, which is 4 minus 1, then 3, then we have the equation which is multiple of 3n, means we have already formula which is a plus n minus 1 into d, where d indicated by the difference and a indicated by the first term of the series. Then substituting the values, then we get 3n minus 2, and second term which is 2, 5, 8 and so on, then we get 3n minus 1, and third term which is 3, 6, 9 and so on, then we get 3n. Then our un becomes x raised to n minus 1 upon 3n minus 2, 3n minus 1 into 3n. Now here we can say that x which is constant value, then constant raised to n. Then our form of constant raised to n or a factorial form, then we have to apply the Albert ratio test. Then according to the ratio test, n replaces as n plus 1. Then we get x raised to n upon 3n plus 1, 3n plus 2 into 3n plus 3. Now, firstly, we have to take on the ratio and simplify that term. Then we have to apply the limit. Then here un upon un plus 1. Substituting the values of un and un plus 1 and give the simplified, and each and every term of the numerator n which is common, same manner denominator portion, each and every term has n common and cancel out. Then its term become 3 plus 1 upon n into 3 plus 2 by n into 3 plus 3 by n into 1 upon x in denominator portion, 3 minus 1 upon n, 3 minus 2 upon n into 3. Here we have to take on the ratio un upon un plus 1. If you want to take the ratio un plus 1 upon un, then doesn't matter. Any ratio you can take on un upon un plus 1 or un plus 1 upon un as you like. Now applying the limit to the ratio, limit n tends to infinite, un upon un plus 1. Now n as a infinite, then 3 plus 0, 3 plus 0, 3 plus 0 in denominator portion, 3 minus 0, 3 minus 0 into 3, then 27, 27 which is cancel out, then 1 into 1 upon x. Here we don't know what is the exactly value of x, means we have the answer in form of range, means according to the D'Albert ratio test, we have the condition, our limit which is greater than 1, then it is convergent, or our limit which is less than 1, then it is divergent. If it is convergent, then 1 upon x which is greater than 1. Now simplified that term, then we can say that x which is less than 1, means in our question, we have a question in condition where x greater than 0, means value of which is lies between 0 to 1, means 0 less than x less than 1, our given series is convergent, or greater than 1, our series is divergent. I mean 1 to infinite series is divergent. But what about x equal to 1? Then according to the condition 1 upon x equal to 1, that means x equal to 1, we can say that given test is failed. Now that case we have to apply another test. Then substituting the values of x in our un, then it becomes 1 upon 3n minus 2, 3n minus 1 into 3n. Now simplify that term, which is 1 upon n cube 3 minus 2 by n into 3 minus 1 by n into 3. Here denominator portion which is in form of polynomial form, or we can say that different power of n. Then obviously we have to apply comparison test. Then for the finding the Vn, then dominant term of numerator portion and dominant term of the numerator portion. Numerator portion has a 1 and denominator portion has a n cube. Then 1 upon n cube, that is our Vn. Now let's see the our Vn is convergent or not. That is based on power series. And firstly, we take applying the limit n tends to infinite to the un by Vn, substituting the values of un and Vn and give the simplified, then it becomes 1 by 27, which is finite and non-zero. Now let's see the check out the sigma Vn is convergent or not. Then sigma Vn equal to sigma 1 upon n cube. Then here value of p equal to 3, which is but obvious greater than 1. Then according to the p series, we can say that sigma Vn is convergent. Now both the series either convergent or divergent together. Then according to the limit comparison test, sigma un is also convergent for x equal to 1. That means, now summary of the convergence and divergence. Given series is convergence for x less than or equal to 1. That means 0 less than x less than or equal to 1. 1 which is included to the convergence range, or divergence for the x greater than 1 means 1 to infinite. But x equal to 1 means series is convergent. Now let's see the one more example. Test the convergence of the series summation n equal to 0 to infinite n plus 1 upon n plus 2 raised to n into x raised to n, where x greater than 0. Firstly, un equal to n plus 1 upon n plus 2 raised to n into x raised to n. Firstly, how you can identify which test is applicable? So here something raised to n, then what obvious, we have to apply root test. Then here nth root of un, that becomes n plus 1 upon n plus 2 into x. Now for the simplification of that term, means numerator and denominator portion n which is common and cancel out. Then applying the limit n tends to infinite to the nth root of un, then it becomes limit n tends to infinite 1 plus 1 upon n in divided by 1 plus 2 by n into x. Now n as an infinite, then 1 plus 0 upon 1 plus 0 into x, then it becomes x. We don't know what is exactly value of x. Then here we get the in terms of branch, means what value of x which is convergent and divergent. Then according to the Cauchy root test, given series is convergent for x less than 1, means limit which is less than 1, means here we have the condition x greater than 0, means 0 less than x less than 1 given series is convergent, and for the x greater than 1 given series is divergent. Now but what about x equal to 1? Then for the x equal to 1 given series, we cannot say about the convergence and divergence, means test is failed. Now substituting the x equal to 1 in un, then it becomes n plus 1 upon n plus 2 raised to n. Here numerator and denominator has a same power of n. Then obviously we have to apply zero test, or we can say that divergence for the test for divergence or a divergence theorem. Then here numerator and denominator portion has a n raised to n which is common and cancel out. Then it becomes 1 plus 1 upon n raised to n in denominator portion 1 plus 2 by n raised to n. Now applying the limit to the un, and we already aware about the according to the standard limit n tends to infinite 1 plus 1 upon n raised to n, that is e, and denominator portion has a limit n tends to infinite 1 plus 2 by n raised to n, that is e square. Now substituting the value e and e square, the e which is cancelled, then 1 upon e. You all are aware about the value of e which is 2.718, which is but obvious not equal to 0. Then according to the zero test, we can say that given series is divergent for the x equal to 1. That means given series is convergent for the 0 less than x less than 1 means inside the range of 0 to 1, and divergence for the x greater than equal to means 1 to infinite, 1 which is including to the divergence condition. This all about the topics, power series and absolute and conditional convergence of the series. I hope you guys you learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with this video with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any doubt regarding this topic, then feel free contact me. Thank you so much for watching me.